In this video, we're going to talk about conducting hypothesis tests that involve either a mean or a standard deviation. So here are the steps again for a hypothesis test. So let's look at step 1 again. Here we want to determine the null and alternative hypotheses. One way we can do this is first to write down the claim or the statement being made. Then what we want to do is translate the claim or the statement into an alternative hypothesis. And to do that, we answer these questions. First of all, which parameter are we testing? In this chapter, it's going to be either a mean, a proportion, or a standard deviation. So for the parameters, if we have a mean, we want to use mu. For proportion, we use p, and for a standard deviation, we use sigma. The next question is, which inequality should we use? This is one of the reasons that we need to write down the claim or the statement in lots of detail. So the possible inequalities we can use can be a less than, a greater than, or a not equal to. They cannot have an equals as part of them. And the third thing we want to know is what's the value of the parameter that's stated in the claim. And this can't ever be something that comes from the sample data. Then when we've answered those three questions, we should be able to write down the alternative hypothesis in symbols. Once we have the alternative hypothesis, we can write the null hypothesis just by replacing the inequality symbol with an equal sign. So here's some examples of writing null and alternative hypotheses. In this one, the claim is that the Federal Aviation Administration claims that the mean weight of an airline passenger, including carry-on baggage, is less than 195 pounds. So we're going to go through those steps. So first we're writing the claim as a complete sentence. So that would be the average weight of an airline passenger, including carry-on baggage, is less than 195 pounds. So we included details about what our hypothesis test is about. We included something that tells us something about our inequality, whether we're talking about less than or more than or something different. And we also included a number in here. Then we're going to translate that into our alternative hypothesis. So first of all, which parameter are we testing? Because this says average, average is another word for the mean. So what we're testing is the mean. That means for our symbol in our alternative hypothesis, we'll use the symbol mu. Then which inequality should we use? In this one, it actually says less than. So less than translates to a less than symbol. And then what's the value of the parameter in the claim? It was 195 pounds. So we'll take those three things and write our alternative hypothesis, which is going to be mu is less than 195. Once we have that, our null hypothesis is exactly the same, only we're replacing the inequality with an equal sign. Here's another example. Data from the National Health Survey showed that in 2009, 18.9% of adults consumed herbs. A recent study claims that the percentage of adults consuming herbs has changed since 2009. Again, we're going to start out by writing our claim as a complete sentence. So we're just repeating the claim that was up here. And also notice in here I added in this part that actually said what the number was that we were comparing against. So in 2009, the percentage was 18.9%. That's going to be an important part of our alternative hypothesis. So then to translate this, what parameter are we testing? Since we're talking about a percentage is really the same as a proportion. So the parameter we're testing is the proportion, and that's going to be a p in our symbols. What inequality should we use? If we say it has changed, that doesn't say anything about more than or less than, so that's going to translate to a not equal to. And what's the value of the parameter in the claim? That's the 18.9%. That's why we wanted to include that as part of our written claim. So then our alternative hypothesis is that p is not equal to 0.189. Notice here we went from a percentage, and here we put that percentage into a decimal form. And then our null hypothesis, we're just changing the not equal to an equal to. One more example. In this one, we're looking at cans of 7-Up, and the engineer is worried that the filling machine is miscalibrated and creating too much variation in the volumes of the filled cans. That's kind of a key word there when we're talking about the variation, because variation has to do with the standard deviation. So then it says if the standard deviation is more than 3.2 milliliters, the filling machine will need to be recalibrated. So what we're trying to test is the claim that the standard deviation of the can volumes is more than 3.2 milliliters. So we're going to start out writing our claim as a complete sentence. So that's just that the standard deviation of the volumes of the filled cans is more than 3.2 milliliters. Now we want to translate that. So which parameter are we testing? We're talking about the standard deviation. So the symbol for the standard deviation is the sigma. What inequality are we using? Where it says more than here, more than is going to translate to a greater than. And the value of the parameter in the claim is the 3.2 milliliters. So our alternative hypothesis is that sigma is greater than 3.2. Then our null hypothesis, we're just replacing the greater than with an equal sign. So our null hypothesis is that sigma is equal to 3.2. Now when we do step 2 of our hypothesis tests, most of the time for the problems that you get, we'll already have the significance level given to us. But if we don't, then we have to think about the consequences of a type 1 error. So just to review what type 1 and type 2 errors are. For a type 1 error, that would be rejecting the null hypothesis when the null hypothesis is actually true. So in other words, this would be finding sufficient evidence to support our claim when the claim isn't actually true. A type 2 error is the other way around. So this is when we do not reject the null hypothesis and the alternative hypothesis is actually the true one. So this would be if we didn't find sufficient evidence to support our claim, but our claim was actually true. So let's look at identifying some type 1 and type 2 errors. So in this problem, a researcher claimed that the mean length of a call has increased since March 2006, and in March 2006 it was 3.25 minutes. So if we were going to test this claim, the hypotheses would be this. The alternative would be that mu is greater than 3.25. The null hypothesis would be that mu is equal to 3.25. If we have these two things, then we can identify our type 1 and type 2 errors. So type 1 is rejecting the null hypothesis when the null hypothesis is actually true. In terms of our claim, that would be concluding that the mean length of a call is greater than 3.2 minutes, because that was what our claim was, when that's not really true. For type 2, this would be failing to reject the null hypothesis when the alternative hypothesis is actually true. So this would be, in other words, not supporting our claim, so concluding that the mean length of a call is not greater than 3.25 minutes when it really is greater than 3.25 minutes. Here's another example of type 1 and type 2 errors. So back to our problem with the average weight of an airline passenger. Here are the hypotheses that we came up with. So for a type 1 error, this is again rejecting the null hypothesis when the null hypothesis is true. So in this problem, it would be rejecting the null hypothesis, in other words, supporting the claim. So concluding that the mean weight of an airline passenger is less than 195 pounds when it really isn't. Type 2 would be concluding that the weight of an airline passenger is not less than 195 pounds when it really is. And again, the reason that we really want to identify type 1 errors is because we want to think about the possible consequences of these if we're trying to decide on a significance level. So if we think about the consequences of a type 1 error in this case, If we concluded that the mean weight of an airline passenger is less than 195 pounds when it really isn't, that could run us into some serious safety issues. If the airlines are basing the number of passengers on this mean weight, if the mean weight is really heavier than 195 pounds, they could end up with an airplane that's overloaded, that's actually carrying more than it's really capable of carrying, and that could cause some problems with the airplane. So this would be a fairly serious consequence of a type 1 error in this case.